This video will show how to solve an initial value problem when there's a step function involved in the non-homogeneous part. So first, we have a differential equation second order with two initial values, y0 and y prime 0, okay, where f of t is a step function. Then how can we solve this IVP using Laplace transform? All right, let's first, again, we want to use Laplace transform, so we have to apply Laplace transform to both sides of the equation. T. Okay, and then f of t is a unit, is a step function, means we want to convert this piecewise function into a step function. So f of t is going to be equals to t, right? Plus the step units is 1, t, and the coefficients would be 0 minus t. And then I can rewrite this in terms of t minus u1t negative positive t. All right, so this is my step functions f of t, and we want to find the Laplace transform of these functions here. Okay, well, let's try to do it on this side. So if I want to apply Laplace of here to here, okay, first I can just use the linearity of Laplace transform to break it into two different functions. One is just the regular function, another one is a unit functions, right? And then as we know that this is going to be just 1 over s squared, how about this unit step function? And that reminds us that in step functions, we want to come up with, we want to have a correct form before we try to find the Laplace transform. So the correct form of step functions is you need to have the Laplace of uc, right, where c is a step unit of the function f of t minus c will give you the form of e to the negative cs multiplied by big F of s, where big F of s here is a Laplace transform of f of t. Okay, and then we look at this functions. You have the unit step, the step unit is 1, that means, and the functions that we identify at this point should be f of t equals to t, right? But then we want to convert it into this form, f of t minus c. So f of t minus c should be t minus 1, because c is 1. That means we need to somehow transform this into functions in terms of t minus 1. Okay, so that will be the next step. All right. So the next step is we translate this u1t, right? And the function t minus 1. And at this point, we have the correct form, t minus 1, and this is unit step. Unit is 1. But then we need to plus 1 in order to preserve the equivalency, right? T minus 1 plus 1 is just t, which is the original functions. Well, we keep going with this. It's just 1 over s squared minus, and using linearity, I can break it down into two different functions. T minus 1 add u1t of 1. Okay, so 1 is here, t minus 1 is here. I just break it down into two different step functions. Okay, and from here you can see that I just keep carrying it down because the goal is finding the Laplace transform of f of t, right? 1 minus s squared. And this one, we know that, so using this formula right here, the Laplace transform of f of t should be 1 over s squared, and c is 1, so the Laplace transform of this step functions here, of this step functions here, is e to the negative s multiplied by 1 over s squared. All right, and the Laplace transform of this step functions here, it should be just the unit step function, and the Laplace transform of the unit step function is e to the negative s still, because c is 1 multiplied by 1 over s. Okay. So again, we just found the Laplace transform of this step function. Okay, and we can bring this result over here. All right, so we just do separate parts of the problem and put everything together. And on the left side, keep in mind that the Laplace transform of y double prime equals to s squared times the Laplace transform of y minus s times f of 0 minus f prime of 0. Okay, so this is something that we want to keep in mind. And then using that formula, I can break this into two Laplace transform using linearity. Okay, and then I just keep Laplace transform of f of t at this point because I know that this is the Laplace transform of f of t. From here, I use this formula. I have s squared multiplied by Laplace transform of y. F0 is 0, f prime 0 is 0, so it's just going to be 0, and then you add 4 Laplace transform of y equals to Laplace transform of f of t. Okay, this point is when, again, you always want to group Laplace transform together because the goal is to find it. So s squared plus 4 equals to, now I can replace Laplace transform of f of t equals to 1 over s squared minus, e to the s 1 over s squared plus 1 over s. Okay, and then I can just solve for the Laplace transform of y equals to 1 over s squared plus 4 minus e to the negative s 1 over s squared plus 4 plus 1 over s squared plus 4. All right. So now I have this Laplace transform, and the goal, the next goal is to find y, right? And the ultimate goal is to find y. And in order to find y, you just need to apply the inverse of Laplace to both sides, because the inverse impose L is y, okay? And this is the goal right now, finding the inverse of this Laplace transform. Well, this is just the functions, right? And this should be a unit functions because we have e to the negative s here. So unit function of these functions. Let's figure this one out. For the 1 over s squared plus 4. Okay. Luckily, in the previous problem, we found that 1 over s squared plus 4, using partial fraction, it is, let's see. Using partial fraction, you get 1 over 4s squared minus 1 over 4s squared plus 4. Okay, we can use this result for this fraction as well. And 1 over s squared, the inverse Laplace of 1 over s squared should be t. And this should be s squared plus 4. You think of 1 over s squared plus 4, you think of sine, right? Sine of 2t, because 4 is 2 squared. Sine of 2t, then you need to have 4 up here, or you need to have 2 up here. If you need to multiply 2 here, you have to multiply 2 in the bottom. So what left is you have 1 over 8 times sine of 2t. So this is the inverse of the first part of this part. Okay. For this part right here, e to the negative s, 1 over s squared plus 4, plus 1 over s squared plus 4. We already have gone over this problem in the previous video. It is here. So we found that the inverse of e to the negative s, 1 over s squared plus 4, plus 1 over s squared plus 4 equals to this function, u1t, right? Because the step function, the step unit is 1. Just want to copy it, right? And this step, you have 1 over 4 t minus 1. And negative 1 over a sine 2t minus 1. And you have plus 1 over 4 minus 1 over 4. Cosine of 2t minus 1. Okay. So as we know that, I want to denote it properly. So the Laplace transform, the inverse of this is this. And the inverse of this would be the inverse of 1 over s squared plus 4. Okay. Well, now we found the inverse of this. So we found the inverse of this function. We found the inverse of this function. That means we found y. That means y equals to t minus 1 over 8 sine 2t. Or it should be 1 over 4. 1 over 4t. Because of 1 over 4 over here. Okay. So 1 over 4t minus 1 over a sine 2t plus u1t 1 over 4 t minus 1 minus 1 over 8 sine of 2 t minus 1 plus 1 over 4 minus 1 over 4 cosine of 2 t minus 1. So this is y. I just combine everything together to get my solution y, right? Pretty long solutions. Well, the next question is, can I rewrite these solutions in terms of piecewise function? So this is the function where we started. That means y t equals to these functions. Okay, for t is less than 1. Because 1 is the first unit step unit. And then what is the next functions when t is greater than or equals to 1? When t is greater than or equal to 1, my function should be the, so you can see that in order to form these functions here from a piecewise function, this functions here has to be the difference between the first and the second function. That means when we try to find convert from a piecewise function to a unit function, in order to find these parts right here, we take the value of the second functions and we subtract the value of the first function. So in order to do it, in order to do the reverse step, we just need to take the value. In order to find the second functions, you take the first functions and you add to the first function here and you add to these functions, right? Negative minus 1 is 0. You see that? So we want to find this 0 here. We just need to take this function and add to these functions. Very similarly, if I take these functions and I add to these functions, I would have the functions here. Okay. What happens when you add them together? See, and maybe I should try to simplify this a little bit. So you have 1/4, negative 1/4 here, so 1/4 is gone, right? You have 1/4 t. Okay, and then you have, what else do you have? You have, one thing is this is negative, so I should have a negative here. Negative. Okay. To be careful with all the sign. Okay. So do it in your mind, right? I can try to simplify this real quick. So in this case, I have 1/4 t minus 1/4 minus 1/8 sine of 2t minus 1 plus 1/4 minus 1/4 cosine of 2t minus 1. Okay. Well then 1/4 and 1/4 is gone. Okay. If you add, and then remember you have a negative, so have you bring a negative here. Okay. If I add these two together, you will see that 1/4t minus 1/4t is 0. I have negative 1/8 2t. Okay. Negative 1/8 sine of 2t. And I still have sine, negative 1/8 of sine of 2t minus 1, this term. And I still have this term right here. So I should leave a little more room for this. So the last term is negative 1/4 cosine 2t minus 1. Okay, for t is greater than or equals to 1. All right. This is how you, again, this is how you convert from a step function in this form into a piecewise function. You always want to start with the first functions at the first function here for t less than 1. You shift it, right? And then for the second functions, you always want to take this function and you add this function. Whatever the sum of this and this function will be the second functions here. Versus when you try to convert from a piecewise function to a unit step functions, you want to start with the first functions here, and then go to the unit step, right? Step units 1. In order to find this function, you just take the second function minus the first function because you want to find the distance between the two functions. All right, so this is an example of how you use Laplace transform to find solutions to an IVP problem where is involved a step function.